So here's what we're going to be covering this week. It's going to be all Python, 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 Python. So today we're covering some basics. We're going to go over strings, math, variables and methods, functions, Boolean expressions, relational and Boolean operators, and conditional statements. If you've never done coding before or you've never done Python before, this could sound very foreign to you, and that's A-okay. On July 1st, which is Friday, we'll be covering the other side of this, which is lists, tuples, looping, modules, advanced strings, dictionaries, sockets, and if we have time, we'll build a port scanner. Otherwise, we'll make that homework in the academy. So, a couple updates for today. Attendance will be tracked via a Google form. So, if you are in the academy, and I am slow and did not bring this up, let me bring this up really quick. If you are in the academy, we have updated the way we are doing tracking. So if you come in here, we full screen this, you can see that we have this attendance tracker in here. If you click on that, you'll be brought to the attendance tracking form. If it says, hey, if it says, hey, we are no longer accepting responses, that means the attendance tracker is not on. You will also see in the upper corner of your screen that there says something says attendance off. That means we're not currently tracking attendance. So keep that in mind when you are looking to do your attendance. So we will do, as always, a random point in the stream. You'll come in here, you'll type in the code word. All of it's done through your academy. So if you are not enrolled or registered at the academy or the PNPT Live, you need to go ahead and do that. So that way you can use the attendance tracker within here. Okay. So growing pains, week one kind of sucked. We learned from week one, and now we are week two. We're making it so hopefully we don't get DDoS on this. Otherwise, we have a new course out today, brand new course out today. If you go to the academy, you should be able to see that course. I'm going to bring it up here. That brand new course is Practical Windows Forensics. Somebody told me the logo is too uwu. That's okay. You can never be too uwu. We've got the course on Windows Forensics. It is now live as of just a few minutes ago. So if you're interested in learning Windows Forensics, this is taught by somebody who is X-Team Red, IBM. It's really, or X-Force Red, I should say. It's a really good course, glowing reviews from the QA. So I think this is going to be another hit. Anyways, let's quickly talk about why we're learning Python. So Python. We are building our foundational skills. If you remember from week one, day one, we talked about, hey, we need basic IT skills. We need some networking skills. We need some Linux skills. So we covered networking. We've covered Linux. You were expected to already know some networking and basic IT coming in here. We've covered some scripting, but we also need to cover coding. So if we are going in and we're doing exploits, right? If we're downloading exploits off the internet, a lot of time they're going to be in code, and we're going to need to modify that code and run that code. Sometimes we might need to build out scripts. We might need to understand what the code is doing. Now, this means that we don't have to be developers to be ethical hackers. That's one of the biggest questions that we get. Do I need to be a developer? Do I need to know how to code to be an ethical hacker? No. It helps to know how to code, but at the end of the day, as long as you understand how to read the code and what the code is telling you, that goes a long way, and you can still be a successful hacker, if you say, without knowing how to code fully. So we're going to go ahead and switch over now into our Kali machine. So everybody get their Kali machines ready. We're going to go ahead. I'm going to log in. I'm logging in as Kali. And go ahead and bring up a terminal if you shall. I'm going to make this a little bit bigger. So I'm going to make a new directory today. I'm going to make a directory, and I'm just going to call this Python. And we're going to cd into Python, and we're just going to do all of our work within Python here. Okay. So what we're going to do is we're going to use mousepad, and we're going to just make a thing. We'll call this first.py. We're going to test out running Python first and kind of look at it and see how to navigate around, and then we'll go ahead and make a script that we save the rest of the time through. All right. So from here, what we need to do is we need to do a shebang bin Python 3, just like this. So remember, we did this when we were scripting out when we were scripting out in Bash, right? We did a bin bash. In here, we're calling out Python. So when we run this code, we have the option of saying and declaring Python3 first.py, or we could say something like ./first.py. When we run it like this, we already know, or our system already knows where Python 3 is. But if we execute it like this, we don't know where Python 3 is. So we're telling it at the beginning that, hey, we want to run this with Python 3. If you're always planning on running it with Python 3 like this, it's fine to not put this in there, but best practice dictates that we do put the shebang in there up at the top. All right. So with that, we're going to go ahead and save this. Control S, save. And why we save it is it changes to pretty colors, and we can kind of color coordinate what we're doing in here. All right. So the first thing we're going to do is we're going to put in a comment. Now, a comment can be written with a hashtag like this or a pound symbol, and we're just going to say print string. And the first thing that any programmer does when they're learning to code and program is they do a hello world. So they say print hello world like this. And what we're doing is we're just going to print out to the screen hello world. So we can go ahead and save this. Again, Control S. And we're going to close out of this. And then we're just going to say Python 3 first.py. And you can see in here that it says hello world. So I'm going to tab up a couple times. And when we run the script now, I'm going to put the ampersand at the end of it. That's going to allow me to have this open and allow me to run my Python script without having to close this down every single time. So I wanted to show you the differences there. So with this print statement, we can print strings in a few different ways. We could say print, and instead of using double quotations, we can use single quotations like this, hello world. We can also print with multiple lines. So if we say print, and then we use triple quotes, we could say this string runs, hit enter, multiple lines, and do something like that. And we can also say print, this string is +, awesome. And what are we doing here? Well, we're doing what's called concatenating. So you can see that I took this first string and I put a space at the end because you have to put the space. You do a +, then you put another string together, and you can see that it says awesome. So it should print out this string is awesome. So we'll save that, and then we'll come in here and we'll just try running that real quick. And you can see that if we Alt-tab back over, we can print hello world, this string runs multiple lines, and this string is awesome. Now I'm going to go ahead and take a break here, let you catch up. I see some people talking about the attendance. There is a known issue with Teachable that you either need to use a VPN or you have to have the correct browser settings. If this is your first time watching the class and you've never been in Teachable before, and this is the first time you're seeing this issue, that is problematic. Now we do have the tcm-stack.com/attendance as the alternative option. You can still run through that as well. So if you're having issues with Teachable, you can try running that. Otherwise, you need to look at the FAQ or the pins to fix the no-show of the Teachable stuff. So anyways, let's go ahead and go back into the Python stuff. So we have printed our strings. Now we're going to go ahead and show that we can do a few other things as well. So let's say we wanted to print out a new line and continue on with this. We can do something like print n like this, and that'll print out a new line. And we could come in here, if you want to save this, you can come in here and add stuff to all these. Like we could say, hey, we can run double quotes. We can run single quotes. We'll add comments to all these lines. We can run triple quote for multi-line. And we could say, we can also concatenate. It's always hard for me to type. So this new line will print out a new line for us. So it'll give us a space. And then we can go in and start talking about other stuff. So currently, we've talked about strings. Now, strings are nice. We'll build upon those as we go. Python has a lot of cool features built into it automatically. We could take math, for example, and we could say, let's just comment this and say math. We'll just make it big. Okay, so for math, we have a bunch of things that we can do within Python. We can come in here and we can do, I'm just going to type this out and follow along with me. We can do 50 plus 50. So we can print this out. And this is adding. We can subtract 50 minus 50. Okay. We can multiply, of course. And we can divide. Do 50 divided by 50. So it's all pretty straightforward. Now, if we save this and we run this, let's take a look at what it does. So if you see the script that I ran, I did 50 plus 50, which is 100. 50 minus 50 is 0. 50 times 50 is 2,500. And then we see 50 divided by 50 is 1.0. And that's the only one that we get a point on. So we're getting a decimal point, which is called a float. And we'll talk about floats here in a little bit. Just know that there are certain ways that we can divide, and we're going to go over those now. So a couple of advanced ways that we can do math within Python here. We can do print 50 plus 50 minus 50 times 50 divided by 50. And what do we think this is going to do? This is going to do PEMDAS, right? Please excuse my dear Aunt Sally. So we should have all learned this, hopefully, in school or some form of this. And we can also do exponents. So we could do 50 to the second power. All right. We can do what's called a modulo, and we'll cover what this does here in a second. Let's do 50 divided by 6. So this is a modulo, which we could just take this down as it takes what is left over. Okay, let's save right here, and then we'll go back into division. So if we print this out and we say, let's take a look at this now. So starting from the PEMDAS, we really don't care what the answer was, but it will do PEMDAS type printing in math equations here. We can also do the exponents. 50 to the second power is 2,500, similar to 50 times 50. Now the modulo, 50 divided by, and I typed this wrong, I'm sorry, modulo. 50 divided by 6, okay, there's a leftover of 2. So it takes what's left over. Now 6 doesn't go into 50 2 times. No, it has 48 and then it has a 2 left over, right? So we could take what is left over of a value. We can also do decimals like you saw, 50 divided by 6. And this is division with decimals. We can also do print 50 divided by 6 with 2 forward slashes, and this will be no leftovers. So let me go ahead and save that. I'll bring this back up so you can follow along. I'm just going to print and kind of explain. All right, so we saw the modulo has 2 left over, right? Well, if we did just true division, 50 divided by 6, we'll see that we have 8.3 forever, and then we round up to the 4. So we have a float here, which again, anything after the period is the float. And from there, we can also do division with no leftovers. Let's just say we want to know how many times we can go into it and just know that first number. We can just pull the 8 with the 2 forward slashes. All right, so that's a little bit of math. We're going to get back into that here in a little bit. We're just covering the basics for now. All right, so the next thing we want to cover are what's called variables and methods. So I'm going to go ahead and type that out. Variables and methods. Okay. A lot of you are more concerned about attendance than you are about actually learning, and that's troublesome, honestly. Leftovers are called remainder in math. That's correct. I'll even add that. No leftovers or remainder. Okay. So what are variables? Well, a variable can be something like this. What if we say quote, and then we put a string into a quote? We say all is fair in love and war. Okay, and then we print out the quote. We save that, and we run our Python script. You can see it prints out all is fair in love and war. So what we're doing is we're storing everything into one item, and this is a variable. And this variable is called a variable because variables can change. All right. So we'll get more into changing variables just in a little bit, but instead of printing a string out like we were before, we can store that string into a variable. And from here, we can go ahead and print that or call that back out later. So let's talk about what a method is, and then we're going to apply this to all this. So a method, best way of thinking of a method is we could think of it as a function that are available or functions that are available for a given object. Now we haven't gotten into functions yet, but we could think of functions as like mini programs and things that are we can build out as well. But these are already built into Python. So let's say that we want to print some stuff with this quote here. I'm going to move this up just a little bit. So if we want to say print the quote in uppercase, we can with the upper feature. And we'll just say uppercase. Or guess what? We can also print this in lowercase. We can also print this in title case. Okay, so these are all little mini programs that do a little bit of extra stuff for these. And these are all called methods. So we'll say title case. And we'll save this, take a look at it. Actually, we'll do one more thing too. Let's print the length of the quote. So we'll say print length, len, like this, and then quote. And that way we can talk about all these and just say counts characters. All right, so save this, print it out. I'll bring it back up so we can follow along if you need to. Okay, so we took this quote and we said, hey, I want to print it out in uppercase. And it did that. And I want to print it out in lowercase. And it did that. And then it printed it out in what's called title case. That is more of kind of camel case, I guess, where every single first letter is capitalized. Even though this isn't perfect for title, like and is not usually capitalized in a title, as an example. So just know title case capitalizes every first letter. And then printing the length of a quote will count how many characters are within this this string or this variable right here. So we have 27 total characters. That does include spaces as well. Okay. Somebody asked why comments get deleted. Comments don't get deleted. Comments are just comments within the script. So the reason we use comments in here is to know what we're doing. So like this is saying, hey, to us, what this is doing is printing in uppercase. So a good developer or a good even script will tell you what's going on in specific locations because the way you develop might be, might be great in your mind or logical in your mind, but you want somebody else to be able to come in, look at your script and understand what's going on because they're not the developer. All right. So it's important to document your code and to have your code be readable to other people. Because what happens if you get hit by a bus? You know, what happens if you write this code, you get hit by a bus, you have no comments or anything? That's going to take somebody way longer to parse through and figure out all these things. So comments are important. All right, so let's continue on with our variables. I'm going to set a variable of my name, and we'll just say Heath. What's your age? I am 33 years old as of today. And that is an int. And I'll actually put a string here too, just so you're familiar. And then we'll go ahead and do GPA. And let's say I had a 3.7 GPA in college. All right. So this is a float, aka has a decimal. Now let's print out the integer of age. Let's also print out the integer of 30.1. Okay. And I forgot a quote there or parentheses. Let's save that. So if we print out age, and we say, hey, I want to print out the integer of my age, which is already an integer, but we're going to say I want to print out the integer of age. We can see that I get 33 back. That's what's stored in here. But let's say I want to print out the integer of 30.1. Well, it's only going to take that first digit because the first digit, or first on the left-hand side of your decimal point, is your integer. Now, if you want a float, the float is the other side, or the right-hand side of your decimal point. Now, let's take one more example. Let's say we print out integer of 30.9. Thank you for all the birthday wishes. I appreciate it. 30.9. And we say, save this, and we print this. What do we think is going to happen here? Will this round up to 31? The answer is going to be no. This does not round, doesn't care what's on the right-hand side of your decimal point. All it wants to know is the first number. Very important. So all we're going to do is 30 here. All right. So keep that in mind when we're dealing with integers and floats. Continuing on with this, we're going to say print. I want to say my name is, I'm going to do a space. I'm going to do a plus sign, name, plus sign, space again. And I am space, plus age, plus sign, space, years old. All right. Now, what are we doing here? We're saying print my name is, and we're make sure we're adding the spaces because it's going to throw Heath in here, but Heath doesn't have any spaces before or after. So we want to make sure we account for spaces when we're writing out this print statement. All right. Now, this is not going to work. This is going to break. All right. I'm going to control S. We're going to see why. All right. This is a great lesson on error codes. We had somebody email the other day about a Python error code, and I said, "Have you Googled it? Do you understand what is? Do you understand what's happening with the error statement? Have you looked it up?" And the errors in Python do a great job of telling you. It'll say, "Hey, literally on line 43, which we're on line 43, it'll say you can only concatenate strings, not integers." So it's referring to age. Because age is an integer. We need to make age a string if we want to concatenate it. So how do we do that? Well, we can convert something to a string. We can say str like this, put age in there, and then when we go ahead and we print this out now, it should hopefully print out. Okay, so now we can see my name is Heath and I am 33 years old. So anytime that you get an error in here, you can read the error, go to Google, look it up, go to Stack Overflow, look it up. Somebody will have had the same error as you before. You are not special, even though your mother may have told you otherwise. All right, so make sure you're Googling your error codes. Now, let's go ahead and move on a little bit. What happens if I am a year older? Okay, so let's say that we go age plus equals 1. We print age. This is important, right? So if we go in here and we print this out, you can see my age has increased by 1. So now I'm 34. So that means that we can change our variables. Again, they are variables. So they can vary, right? So we have 33. Now we change the value of age. It's now 34. We can also set another variable. We could say like birthday is equal to 1. So every time we have a birthday, we can add 1 to it. And we can say age plus equals day. And then if we print age now, we should be 35, hopefully. Okay, now we're 35. So we can do the plus equals, and this comes into play when we start writing for loops and we start doing some scripting. We don't have to worry about it right now, but anyways, so just know that we have the ability to increase by 1 and that our variables can change because they are variables. All right, let's get into functions now, shall we? So let's go ahead and just type in functions. And I mentioned functions earlier as mini programs. They are basically an organized block of code that you define and you can call it later instead of repeatedly typing that code out. Something that we can think of is like when we're doing a print and we do a new line. If we want to put a new line in all the time, we can write a program for that, and we will later on to say, here's how we make a new line. So let's do a print example here. We'll say print. Here is an example function. And within here, we're going to write a function. If I close this off, okay. So let's define who am I. And we need to have a colon after it. And note, this is a function. Okay, so something special about Python is we need to have indentation. If we do not have indentation, then we are going to run into issues. Python requires indentation. Here, if we tab in here, we say name equals Heath. We need to make sure that we are tabbing, okay? Or some people are big on spacing. I just hit the tab. Age equals 33. Okay, and then we can print my name is space plus name. Same thing as before. Plus and I am. Remember, we have to make this a string. Age plus space years old. Something like that. All right. And just because this wrapped on the new line doesn't mean it's actually there. If I make this a little bit wider, it should come back. So, whoops. Sorry. Okay. So we can then call who am I? Like this. And when we call this, we can go ahead and save it, print this out, and I have invalid syntax because I didn't write this in here. Apologies. We need these two in here. So if yours broke, my bad, I forgot to include the parentheses. These become important later. You'll see why we have the parentheses here. Okay. We're going to go ahead and save this. And yes, somebody said I already made age a string. I'll delete that. You're correct. We didn't need the string, but now we do. Okay, so save that. Print it. You can see here's an example function. My name is Heath, and I am 33 years old. So we wrote this function, and then we called it. Now, again, this is like a mini program. Anytime we want to call this same thing will operate and will happen again. Inside this mini program, we have defined our variables. We have the variable of name, variable of age, and what actions to take. We want to print out when we run this. Whatever is stored inside the variables within this function, stay within the function. Okay? So anytime we say if we had a variable called, if we called this like new age, and we called out age now, age would always only stay within this function. So we wouldn't know what new age was. So if we printed out age at the moment, we can do that actually. We just print age. It should come back as 35. So you can see we have two different ages being declared here. One is coming back 35 because that is what we know. Whatever stays within the function stays within there. So that stays as 33. Cool. All right. So let's go ahead and delete that print statement. We don't need it. And let's go ahead and add some parameters. So we're going to write a mini function. Just like say we had no math program, we're going to make our own math program. So let's do adding parameters. We're going to say define add 100. Okay. And within this, we're going to declare num. Okay. So we're going to look for the num variable here. We're going to print num plus 100. So if we wanted to do an add 100, we can call this add 100. And guess what's going to happen? If we put 100 in here, it's going to take the value that is stored within this function, and it's going to take that and then print out that value plus 100. All right, so if we save this, it should print out 200. And it does. Awesome. Okay, let's try multiplying. Let's do multiple parameters, not just one parameter. Let's do multiple parameters. And these are parameters within here. I think I called it a variable. It's definitely a parameter. So multiple parameters here. So let's define the add function. Let's create an adder. We can do x and y. And in here, we can just say print x plus y. Simple. So if we go and we say we want to add two numbers together, like 7 and 7, when we save this, it'll take the value of x, the value of y, and do whatever we tell it to do, which it's printing x plus y. Come in here and save that. Run it again. Should be 14, and it is 14. Okay. All right. So what if we want to multiply then? Same kind of thing. Let's define multiply. If we want to multiply x and y, we can pretty much just do print x times y. Or we could do something like print multiply. Or actually, I'm sorry, we'll return. Let's return this. Return x times y. And then if we did multiply, this is what I wanted to show you. If we multiply 7 to 7, what's going to happen here? Nothing. Nothing happens. Well, we did a return feature. Okay, so we can store this number and then call it later when we want to. Okay, so if we want to print out multiply, for example, we can come in here and say print multiply 7 times 7. And the function still exists. We just have to call it in a way that we want to use it. So we can always store something for later and not call that function with the print command right away. I'm just printing out so that way we can show it on the screen and that it's actually working. So if we save this and we print it, you can see 7 times 7 is 49. Let's do two more. So if we want to define square root of x, let's say we want to know the square root of a number, we can then print x, and we could just take that to the 0.5 power. All right, and if we wanted to square root a number, let's square root 64. Should be a pretty number, pretty clean number, right? Square root of 64. Save that. Print it, and we can see that we get 8 here. So we're just taking, again, we're making math functions here. And you can see define square root, print, and square root of 64 is 8. Okay, one more. So if we go in here and we define a new line, remember we were sitting out there printing new line. We could just do, hey, I wanted to make our own function, new line. And every time I call new line, I want to print out a new line. Easy. So now all I have to do if I want to print a new line instead of typing this is literally just type in NL like that, hit save, and that will print a new line for me. You can see I got new lines in here. All right. Okay, let's go back. If you do not know what a square root is, you need to go back to elementary math. I'm sorry. Google what is a square root. Google what exponents are. This is very, very basic math. I love you, chat, but all right, let's move on. We're going to talk about Boolean expressions. All right, Boolean expressions. I will put this code on the Academy. All right, I will put this code on the Academy. So let's go ahead. We're going to talk about Boolean expressions. Let me make this capitalized. And we can think about Boolean expressions simply as true or false. Simple. All right. So let's print out Boolean expressions. So that way we know in our script where this is. Boolean expressions. Okay. I'm going to write out a few different Boolean expressions here. Bool1 is equal to true. bool 2 is equal to, and I'm going to give you time to catch up and write this, all right? I'm just writing this out, and then we'll explain what we're doing here. No, I definitely mentioned that it is an indent-orientated language. Okay, so Boolean expressions. All we need to know, true or false. If I print out bool 1, bool 1, bool 2, bool 3, bool 4, and we can also print out a type because this will be important here in a second. Bool 1. All right, so Boolean expressions. This is true. 3 times 3, what does that equal? Equals 9. Does 9 equal 9? Sure does. That's true. Bool 3 is false. We could literally say true or false. You could also say 3 times 3 does not equal 9, and that's a lie. So that is false. Okay. So if we come in here and we save this and we print this out, you can see that we printed out true, true, false, false. That's exactly what's being stored in those variables. We're just saying, are we true? Are we false? All right. And from within there, we can also print out the type. So we could say, hey, we're going to use the type method here and say, what is this? This is a Boolean. Okay. So if we ever need to know what we're doing, we can say, is this a Boolean? Is this not a Boolean? Big difference here. For example, if we just do Boolean 5 is equal to true, what is this? This is a string, right? So if we print out type bool 5, you should see that this is going to come back as a string. So the type method here can also help out significantly. Okay. So let's make a new line here. Let's do our new line function that we built out. Okay, so why do we care? Well, we may want to know whether something is true or whether something is false. Think about a conditional statement, which we're going to introduce here in just a little bit. If something is true, we may do X, or if something is false, we may do Y. So it's important to introduce this concept before we move into the heavier stuff. So we might need to know if something is true. We might want to return something. If something is false, we might want to return something else. All right. Okay, so we've got our new line. Let's go ahead and take a look at what are called relational and Boolean operators. So if we're going to come in here, we'll say relational. Okay. So we are going to use an operator. We could think of an operator as greater than, less than, equal to. Okay, so if we called out something like a variable called greater than, and we just set it to 7 greater than 5, well, that would be true. Okay, so if we printed this out, it would say greater than. If we print greater than, it would say it's true. We can also do less than, which is, let's say 5 is less than 7. That would also be true. We can do greater than or equal to, something like this, which would be 7 is greater than or equal to 7. That is true. We can also do less than or equal to, which we could say 7 is less than or equal to 7. So all these are true currently. All right. We can also do and operations and or operations. Okay, so this is going to get a little heavy here for a second. We're going to look at truth tables and talk about this. So let's say we had test and. We said 7 is greater than 5. And 5 is less than 7. This is true. Why is this true? Because 7 is greater than 5 and 5 is greater than 7 or less than 7. So that means that both statements have to come back true. If we did test and 2, we set that equal to 7 is greater than 5 and 5 is greater than 7. Well, guess what? This is false because both statements are not true. So you need two truths for it to be true. anything false within an and statement turns the situation into false, turns the result into false. Now let's look at or statements here. We say or 7 is greater than 5. Actually, I'll just copy this. Might make life a little bit easier for me. Copy, paste, and we'll just say this is going to be true. Okay, so if 7 is greater than 5, and then we put or in here, apologies, or 5 is less than 7, then that returns true. All we need is one value in here to be true. So it's an or statement. All right. We can do test or 2, and we can say same kind of concept. 7 is greater than 5, or 5 is greater than 7. All we need is one statement to be true. So this is true. Okay. So 7 is greater than 5. 5 is not greater than 7, but there we go. So we can use what is called, or what are called, truth tables. One more thing I want to show you before we get into the truth tables. If we do test not, if we said not true, what does that mean? That means that it is false. Something is not true or not false, it would be the opposite. All right. Sometimes it gets hard to think about as well. So if you go to Google and you type in Python truth table, you can see something that looks like this. So if something's not false, it's true. Something's not true, it's false. We have or statements. If it's true or false, it's still true. If it's true or true, it's still true. False or true, it's true. Only in the situation of where it's false or false does it remain false. And statement changes. And then we can actually have not ors, not ands, does not equal, or is equal to. Okay, we've seen does not equal or equal as well. All right. We're not getting into XORs at this moment, but all right. So there's that. And we're going to go ahead and continue on. So we got one more thing to cover, and then we may actually be able to wrap class up a little bit early. All right. So we're going to cover conditional statements. So conditional statements. Conditional statements. I have a tent. Oh, okay. Well, it doesn't really matter. First of all, it's a variable, but thank you. All right. You could say something is intense, like camping, right? Okay. Anyway, when we have conditional statements, we could think of this as if/else. If/else. If you go to the store and you want to buy a drink that is $2, if you have $2 or more, you can buy the drink. If you do not have $2, you will not be able to buy a drink. Let's go ahead and make a new line. And actually, we'll make the new line up here. You guys are appreciating the dad jokes. There's another one that says somebody's running around. They're saying, I'm a TP, I'm a wigwam, I'm a TP, I'm a wigwam. And somebody says, no, you're just 2 tents. Great dad jokes. All right. So let's define that situation we just described. We'll define drink with money. And here we're creating a function, right? And we can say if money is greater than or equal to 2. All right. Additional tab in there. We're going to return. You've got, if I could type. So secret chat, secret time. I use the capitalization or the caps lock to capitalize letters. When I use it within a virtual machine, it sticks on the second one because I'm faster at typing than it is understanding what I'm typing, I guess. So it locks in on that second letter occasionally. But I know I just outed myself. I don't use shift to capitalize. All right, you got yourself a drink. And then else, we're going to return no drink for you. Okay, there's the I hit my capitalization again. No drink for you. All right. So if we print out drink and then the amount of money we have, we've got $3 and print versus drink for $1. Save that, print it out. Okay, so if we have $3, we're going to print out you got yourself a drink. If we have $1, we're going to print out no drink for you because we don't have greater than or equal to $2. If we had $2, we get our drink. Anything less than that, we don't get a drink. Okay, let's run one more and take a look at this. This one's going to get a little bit more complex, and this is the last thing that we're doing today. All right. We define alcohol. Say we want to purchase a drink. Now, listen, I realize some of you don't drink. That's absolutely fine. We're just using this as an example. In order to buy alcohol in the United States, you have to be 21 and you also have to have a certain amount of money. Okay, so you have to, just like the drink, we had to have enough money to buy the drink. So you have to be a certain age and money. So let's say we're going to return age and money in this situation. Okay, so we got a few situations we're coming up with. If our age is greater than or equal to 21, if we're of age and we have enough money to buy the drink, let's say the drink is $5 or more, then we're going to say return, we're getting a drink. We're drinking, all right? Else if, which is ELIF, we're going to return age is greater than or equal to 21. Let's say we have a situation where we're of age, but we're also just broke. We got no monies, all right? So in that situation where we have no monies, we can return with come back with more monies, all right? Else if, we got to think through all the logical situations that we could have here. If we're not of age, but we have monies greater than or equal to 5, we can say return nice try, kid. Okay. And then we can end this with an else statement. If we don't meet any of those conditions, we can return that you're too poor and too young. Story of our life for quite a long time, right? Or still, maybe. All right. So, with this in mind, let's print out a few situations. Let's say print alcohol, and let's say we're 21. We are 21, but we've only got $5. What if we are 20 years old and we've got $5? And then what if we are 20 years old and we've got $4? So, all right, we're back. We're back. Maybe. Are we back? Good. Happy times? Okay. Stand by, chat. Stand by.